Many people find binary very confusing. The purpose of this chapter is to show you that with a little knowledge, a pen and paper, just about anyone can work out a dipswitch setting. The numbers we use in daily life consist of the digits 0, 1, 2, 3, all the way to 9. Every conceivable number you can think of can be written as a combination of those numbers. In the binary world, though, we have only two digits, 1 and 0. Every conceivable number can also be written in binary, using just those two digits. So how does binary look? Well, much the same as ordinary numbers. It's just a string of digits, and in the case of binary numbers, a string of ones and zeros, like this for instance. So let's try and decipher this particular binary number. Every digit in the binary number has an equivalent number in the normal number system. To calculate the value of this binary number, all we have to do is add together those normal values where there is a 1. In our case, that means 256, 128, 16, 4, and finally 1. Add them together and you get 405. And this is another example. 64, 32, 16, and 2, making 114. And this is a third example. How does this apply to dipswitches? Well, since a dipswitch consists of a row of switches that can either be on or off, you can compare the switches to the digits in a binary number. An on switch equals 1 and an off switch equals 0. Remember, each digit or switch has been assigned a value. 1, 2, 4, 8, 16, 32, 64, 128 and 256. Let's see an example of this in action. In this example, we set to on switches 1, 4, 5 and 8. Look at the corresponding decimal values. 1, 8, 16 and 128. Add them all together and the resulting DMX address is 153. Flip the switches and you alter the DMX address. So far we've shown you how to read a dipswitch. But what if the other way around? What happens when you know the address and you have to figure out the dipswitch setting? Well, it's a good idea to have a pencil and paper. Let's just say that our target DMX address is 405. The question is, how do we represent that with a dipswitch? Let's start by writing down the figure 405. Look at the figures below. Pick the largest number equal to or smaller than our figure 405, in this case 256. Subtract that from 405. The remainder is 149. Now pick the largest number equal to or smaller than 149, which is 128. Subtract this from 149. This gives the remainder 21. Now continue by picking the largest number equal to or smaller than 21. In this case, 16, and subtract that from 21 to give 5. Continue like this until you are left with a remainder of 0. Now it's just a matter of switching on those switches that represent those values that you picked. That means switches number 1, 3, 5, 8 and 9. Let's double check and actually turn on those switches. This gives the result 256, 128, 16, 4 and 1. Add them together and we're left with the number we were looking for, 405. If you would like more help or more practice in dipswitch setting, we've included on the DVD in the chapter extras a dipswitch calculator. Sorry about that.